Welcome to homework.
So for part A, let's denote the battery EMFs as V1 and V2. And applying Kirchhoff's loop rule to the circuit, we will get V2 minus IR2 plus V1 minus IR1 minus IR to be equal to 0, where I is the current flowing through the circuit. So this will give I to be equal to V2 plus V1 over sum of all the resistance. The terminal voltage of battery 1, let's call that to be V1T, where 1 stands for battery 1 and T stands for the terminal voltage. So that is equal to V1 minus R1 times the current. So let me just write that. So the terminal voltage is equal to I times V1 minus I times R1, which is the internal resistance of battery 1, and V1 is the EMF of the battery. So similarly, we can write the terminal voltage of V2 of battery 2, so that will be equal to EMF of the battery minus I times, which is this current, times the internal resistance of the battery. Now let's plug the current in these two equations. So that's the terminal voltage of battery 1, and then we do the same for battery 2. The value of current is same because it's a series circuit. Now the problem tells us that V1 and V2 are each equal to 1.2 volts. And from the graph in figure 27.32b, we see that the terminal voltage in battery 2 is equal to 0, and the terminal voltage of battery 1 is equal to 0.4 volts for R value of resistance to be 0.1 ohm. Now plugging these values in these two equations, we will get two equations which we can solve then, and we will find R1 to be the internal resistance of battery 1 to be 0.19 ohms, or nearly equal to 0.2 ohms. So basically what I did is I substituted this value in the second equation, V1t in the first equation, along with V1 and V2 and this value capital R. So that way I'll have two equations and two unknowns, R1 and R2 are those unknowns. And first I solve for R1 for part A, and then solving for R2 using this same equation, we will find R2 to be 0.29 ohms, or nearly equal to 0.3 ohms. Now you can solve these equations analytically, manually, or you can also uh, use Mathematica in order to solve these two equations. So basically, I use the method of substitution and elimination uh, in doing so. So thanks for watching. I'll see you next time.